The parent graph for both of these functions is the x squared function. And I'm actually going to graph the original x squared as well as the f of x and g of x given here all on the same xy plane, because I think with stretching and compressing it's a little bit easier to see when you can see them right next to each other. So if I graph x squared, that has a point at 0, 0. So right now I'm just going to write it as y is equal to x squared. If you plug in x is equal to 1, you get y is equal to 1. If you plug in x is equal to negative 1, you get y is equal to 1. And if you plug in 2 squared is equal to 4. And if you plug in negative 2 squared is still positive 4. So this is the basic graph for any x squared function. So what's happening in number 1 is that we're actually taking x squared, we're multiplying it by 4. And in the second one, for g of x, we're multiplying it by 1/4. So we want to see how that changes it. So multiplying by 4, what we would say that does to our function is it actually stretches vertically. Oops. So you could think about it as if your original graph right here, if these sort of ends of the graph, if you just pulled them in the upward direction, it actually is going to give it a more narrow appearance. And if we tried to plot a few points for number 1, say if we make a little table x and f of x, in this case if we plug in 0, we still get 0. If we plug in 1, well, 1 squared is equal to 1, but then we multiply it by 4. And the same thing happens for negative 1. If we plug in negative 1 squared is positive 1, multiply it by 4, we still get 4. So if I plot those points, well, it shares the point 0, 0 in common. But now instead of the point 1, 1, we have the point 1, 4, and then negative 1 and 4. And if I graph it, this is what we end up with. So essentially it looks just like the x squared function, but it's just been stretched vertically. So the blue graph is 4x squared. So if we try the same thing for the second graph, g of x is equal to 1/4 x squared, what's going to happen here is that the multiplied by 1/4 is going to compress our graph vertically. So again, let's say maybe if we just tried to make a table to see how that actually works. So if you plug in 0, we still get 0 as the output. If we plug in 1, we get 1 squared times 1/4, so our output is 1/4. And now I'm actually going to try to plug in 2. So 2 squared would be 4 times 1/4, which is 1. And we get the same outputs if we plug in negative 1 and negative 2. So now let me go ahead and graph this. So 0, 0. 1 and 1/4 estimated to be right about there. And 2 and 1 would be right here. And I'm going to do the same thing for the negative values, negative 1 and 1/4, and negative 2 and 1. So if I connect these pieces, what we get is a graph that shape-wise looks the same as the x squared. It's just a little bit wider, and that's because it's been compressed vertically. And so the green graph here is the 1/4 x squared graph.